In the vast expanse of our solar system, new discoveries constantly reshape our understanding of the cosmos. Each new finding adds a piece to the intricate puzzle of our universe, revealing the dynamic and ever-changing nature of the celestial bodies that surround us. From distant galaxies to the planets in our own solar system, the quest for knowledge drives astronomers to look deeper and further into the night sky. In 2016, astronomers using the Pan-STARRS telescope in Hawaii made an intriguing find. This state-of-the-art telescope, designed to survey the sky for moving objects, has been instrumental in identifying numerous celestial phenomena. On one particular night, the observatory's keen eyes detected something unusual, something that would soon captivate the scientific community. They discovered a small asteroid, initially designated 2016 HO3, lurking in a peculiar dance around our planet. Unlike typical asteroids that pass by Earth on their solitary journeys around the Sun, this one seemed to be in a unique orbital pattern, almost as if it were a companion to our planet. This faint object, later given the Hawaiian name Kamoʻoalewa, quickly captured the attention of scientists worldwide. The name, meaning the oscillating celestial fragment, reflects its intriguing motion and mysterious origins. Researchers from various institutions began to study its trajectory and physical characteristics, hoping to uncover its secrets. Unlike most near-Earth asteroids, Kamoʻoalewa seemed oddly familiar. Its size, composition and orbit suggested it might not be just another space rock. The more scientists observed it, the more they began to suspect that this asteroid had a story closely tied to our own planet. Its movements and characteristics hinted at a connection to a place we know well, our very own moon. The possibility that Kamoʻoalewa could be a fragment of the moon opened up exciting new avenues for research. If true, it could provide invaluable insights into the history and evolution of the Earth-Moon system. This realization sparked a wave of excitement and curiosity within the scientific community. The idea that a piece of the moon could be orbiting so close to Earth was both thrilling and perplexing. Scientists began to theorize about how such a fragment could have been ejected from the moon and captured into its current orbit. Could this small asteroid, a mere speck of light in the night sky, actually be a long-lost fragment of our lunar companion? The implications of such a discovery were profound. It could mean that Kamoʻoalewa holds clues to the early days of the moon, a time when our solar system was a chaotic and violent place. If so, how did it end up in its current orbit? Was it the result of a massive impact event on the moon, or did it somehow get gravitationally captured by Earth? These questions fueled a surge of research and debate among astronomers and planetary scientists. And what could it tell us about the tumultuous history of the Earth-Moon system? Understanding Kamoʻoalewa's origins could shed light on the processes that shaped our moon, and by extension our own planet. It could help us piece together the events that led to the formation of the Earth-Moon system as we know it today. The discovery of Kamoʻoalewa presented a unique opportunity to study a potential piece of the moon without having to venture beyond Earth's orbit. This was a rare chance to analyze lunar material in situ, providing a wealth of data that could complement the samples brought back by the Apollo missions. It offered a tantalizing glimpse into the moon's past, a chance to unravel the mysteries locked within its ancient rocks. By studying Kamoʻoalewa, scientists hope to gain a better understanding of the moon's geological history and the events that have shaped its surface over billions of years. And so began the quest to understand this celestial neighbor, a cosmic time capsule potentially holding secrets to our own planet's history. The journey to uncover the truth about Kamoʻoalewa continues, as scientists strive to unlock the mysteries of this enigmatic asteroid and its connection to the moon. Kamoʻoalewa, meaning oscillating celestial fragment in Hawaiian, is a name that evokes the mystery and beauty of the cosmos. This small celestial body has captured the attention of astronomers and space enthusiasts alike. It is a relatively small asteroid, estimated to be between 40 and 100 meters in diameter. Despite its modest size, Kamoʻoalewa has a significant story to tell. This makes it roughly the size of a football field, a familiar comparison that helps us grasp its scale. Imagine a football field floating in the vastness of space, yet it remains a dwarf compared to the moon's vast expanse, which dominates our night sky with its majestic presence. The moon, with its craters, and Maria, is a giant in comparison. Its orbit around the sun is remarkable. Kamoʻoalewa follows a unique path that keeps it in a constant dance with Earth, a celestial waltz that has intrigued scientists. It follows a path that keeps it in a constant dance with Earth, never straying too far from our planet's gravitational embrace. This close relationship with Earth makes it a subject of great interest. Never straying too far from our planet's gravitational embrace, Kamoʻoalewa's orbit is a testament to the intricate gravitational forces at play in our solar system. However, what truly intrigued scientists were Kamoʻoalewa's spectral properties. These properties provide clues about its composition and origin. When astronomers analyzed the light reflected from its surface, they found a striking resemblance to lunar rocks brought back by the Apollo missions. This was a surprising and exciting discovery. They found a striking resemblance to lunar rocks brought back by the Apollo missions. This spectral fingerprint suggested that Kamoʻoalewa shared a similar composition to the moon's surface. This spectral fingerprint suggested that Kamoʻoalewa shared a similar composition to the moon's surface, composed primarily of silicate minerals. Silicate minerals are a major component of the moon's crust. Composed primarily of silicate minerals, Kamoʻoalewa's composition provides a critical piece of the puzzle in understanding its origin. This finding was a critical piece of the puzzle. Pointing towards a possible lunar origin for the asteroid. The idea that Kamoʻoalewa could be a fragment of the moon is both fascinating and plausible. Pointing towards a possible lunar origin for the asteroid, this discovery has opened up new avenues of research. While other near-Earth asteroids have shown similarities to different types of meteorites, Kamoʻoalewa's spectral signature stood out as uniquely lunar-like. This sets it apart from other asteroids. Kamoʻoalewa's spectral signature stood out as uniquely lunar-like. This discovery fueled the hypothesis that it could be a fragment blasted off the moon's surface long ago. A relic of a past cosmic impact. Such impacts have shaped the history of our solar system. Kamoʻoalewa's story is a reminder of the dynamic and ever-changing nature of our solar system. Each discovery brings us closer to understanding the complex history of our celestial neighborhood. The idea of a lunar origin for Kamoʻoalewa raises an intriguing question. This small asteroid, which orbits the Sun but stays relatively close to Earth, has puzzled scientists since its discovery. Its unique orbit and composition suggest a fascinating history that might be intertwined with our own moon. How could a piece of the moon end up as an asteroid orbiting the Sun? To answer this, we need to delve into the tumultuous past of our solar system, a time when celestial bodies were frequently colliding and reshaping the landscape of planets and moons. The most plausible explanation lies in the violent history of our solar system. In its early days, the solar system was a chaotic place, with countless asteroids and comets hurtling through space, often on collision courses with larger bodies. Billions of years ago, during a period known as the Late Heavy Bombardment, the inner solar system was a chaotic shooting gallery, with asteroids and comets regularly colliding with planets and moons. This period was marked by intense bombardment that significantly shaped the surfaces of these celestial bodies. During this period, the Moon, like its larger planetary companion, endured countless impacts. These collisions were not just minor events, they were cataclysmic, capable of altering the Moon's surface dramatically. These impacts, ranging in size from small pebbles to massive asteroids, left their mark on the lunar surface, creating the craters we see today. Each crater tells a story of a violent encounter, a testament to the Moon's turbulent past. Some of these impacts were powerful enough to eject material from the Moon's gravity well, launching it into space. The force required to do this is immense, suggesting that the impacting bodies were traveling at incredible speeds. Scientists theorized that Kamoʻoalewa could be a piece of lunar debris ejected during one of these ancient impacts. This theory is supported by the asteroid's composition, which closely resembles that of lunar rocks brought back by the Apollo missions. The force of the impact would have been immense, launching the fragment on a trajectory that eventually led it to its current orbit around the Sun. Over time, gravitational interactions with Earth and other bodies in the solar system could have nudged it into its present path. This scenario, while hypothetical, provides a compelling explanation for the asteroid's lunar-like composition and its proximity to Earth. It paints a picture of a dynamic and ever-changing solar system where even small bodies like Kamoʻoalewa have stories to tell about the history of our cosmic neighborhood. In the search for the potential impact event that could have birthed Kamoʻoalewa, one lunar crater stands out: Giordano Bruno. Located on the Moon's far side, Giordano Bruno is a relatively young crater, estimated to be around 1 billion years old. Its youthful appearance, compared to the heavily cratered lunar highlands, suggests a more recent formation. The Giordano Bruno crater is significant because its estimated age coincides with a period when Earth experienced a sudden increase in the deposition of a specific type of sediment tektites. Tektites are small, glassy objects formed during meteorite impacts. The increased tektite deposition around 1 billion years ago suggests a significant impact event occurred around that time, potentially ejecting material into space. While there is no definitive evidence linking the Giordano Bruno impact to Kamoʻoalewa's formation, the timing and scale of the impact make it a compelling candidate. If Kamoʻoalewa did originate from this event, it could provide valuable insights into the composition of the lunar mantle, the layer beneath the Moon's crust, which is typically hidden from view.